Alrighty guys, we got our third day of trig here. We'll be talking about values of angles in standard position. It's going to be dynamite. Alright, so this first example here, let's say we have a point 4, 3. So there's a point on the xy coordinate plane, the standard xy coordinate plane. We want to find the exact value of the actual will be 3 trig functions. We're not going to do the other 3 this year, all right? So the first thing we want to do is go ahead and draw a line through that bad boy, and then we're going to drop down an altitude down to the x-axis, and it forms basically a triangle, as you see. So now let's talk about the sides of that triangle, the lengths of the triangle. Well, one of those lengths is going to be 4. There you see the horizontal one. Now the vertical one's going to be 3. So we've basically created a 3, 4, 5 triangle. Well, now we just need to find those trig values, those trig ratios for that angle theta, which is the one that is right there nearest the origin. Well, if it's sine, it's going to be the opposite side, 3, over the hypotenuse, which is 5. So we have 3 over 5. Cosine, adjacent over the hypotenuse, so 4 over 5. And then our tangent will be our opposite, 3, over our adjacent, 4. So we get 3 over 4. No big deal. So again, plot the point, draw a line through it, drop the altitude, it creates a right triangle, figure out the missing side. The hypotenuse is what we do need to figure out. You always need to figure that one out. You're going to be given an ordered pair, you figure out your hypotenuse, and then bada boom, bada bing, you got all 3. Let's try it again. Let's say it's negative 6, 8. All right, so that point is going to be over here in quadrant 2, as you remember, the quadrants from previous lessons. So if we draw that hypotenuse in, drop down the altitude, I've got negative 6 there, 8 for my vertical one, and notice how we have reference. That's our reference angle. Remember, we're talking about our reference angles when we're talking about these trigonometric values. Okay? So my hypotenuse, this is basically a 6, 8 what triangle? Well, that's a 3, 4, 5 doubled, so it's a 6, 8, 10 triangle. And now we can go right through our awesome trig values. My opposite being 8, my hypotenuse 10, so it's 8 over 10, which reduces to 4 over 5. My cosine, adjacent over hypotenuse, well, negative 6 over 10 reduces down to negative 3 over 5. And lastly, tangent, which is our opposite 8 over our adjacent negative 6, so negative 4/3. Not too bad. Let's try one more. Let's say we have negative 5, negative 12. So that's going to be way down there in quadrant number 3. Draw our hypotenuse in. Drop down that altitude for the reference angle. Remember our bow tie for the reference angle. We got negative 5 for our x value, negative 12 for our y value, and then we'll throw in the 13. It's the scale a little bit different, it looks like here on the y value, but you get the point. We wanted to fit it on the graph, okay? Keep in mind that this is for your x, this is for your y. Don't mix these two values up. That's a common mistake, is where students will mix up the x and y values, so don't do that. Now I can just go right through my trig values. Opposite over hypotenuse would be negative 12 over 13. Cosine, which is adjacent over hypotenuse, negative 5 over 13. And then we've got our tangent, which is opposite over adjacent, so negative 12 over negative 5, which is 12 over 5. I think you guys can handle this. Try some examples in your packet. Keep it real, keep it fresh, and always remember to do your best. America.